Welcome to this video from the topic Particle Model of Matter. Today we're going to have a look at changes of state. We're going to have a look at some of the state changes and discuss what we call them, but also some of the key terminology around it. So, first of all, we've got our three states of matter. We have got a solid, a liquid, and a gas. Red is going to represent heating. Whereas blue is going to represent cooling. So, if we add heat to a solid to get to a liquid, we call this state change melting. However, to get back from a liquid to a solid, we remove heat from the system, so we cool it. And we call that state changing solidifying or freezing. Just like that. So we melt to get solid to a liquid, we solidify or freeze to get to a liquid to a solid. If we get to a liquid and we add more heat to get to a gas, we call this boiling. Now sometimes people put evaporation here, but let's go with boiling. And again, if we remove heat from the system to get from a gas to a liquid, we call this condensation. And you can see that on a bathroom mirror. If you have a hot shower and the mirror is cold, it will condense. Water vapour which will change to a liquid. Now, we've got a couple more things to talk about here, because we can go from a solid to a gas. And we actually call this process sublimation. So, sublimation is solid to a gas. That's all you need to know at GCSE, but let's go a little bit further. Because we can also go from a gas to a solid, and we call this deposition. Deposition. So there are all the state changes we need to know, and we'll look at these in more detail as we go through this topic and as we start to have a look at internal energy. However, what you've seen here is an example of something called a physical change. And a physical change, put simply, is a change of state, which means it hasn't changed its chemical identity. If you have a chemical change, you will alter its chemical properties. So here we've got a physical change, which is a change of state. Now, throughout these changes, people might think that the mass changes. Well, it doesn't. If I have a kilogram of ice, I'm going to have a kilogram of water as long as nothing evaporates, for example. And the conservation of mass. And what the conservation of mass tells us is that the mass before a reaction is equal to the mass after a reaction. Now, theoretically, that obeys. However, we do know that if we melt something, and should I say if we boil something, and we go from a liquid to a gas, and some of that water escapes as water vapour out of the system, then you are going to lose some mass. But hopefully if we do it in a sealed container, this obeys. Now, we're going to talk a little bit about pure substances, melting and boiling and evaporation. So, first of all, a pure substance is a substance that has a defined melting and boiling point. So, a defined melting and boiling point. Now, we're going to define these 2 points here. So, melting point. So, the melting point is a temperature at which the substance changes from a solid to a liquid. Compared to boiling point, we can say it's the temperature at which the substance changes from a liquid to a gas. I said earlier that we're going to call this liquid to a gas here. We're going to call it boiling, but we sometimes call it evaporating. And there are subtle differences. So, boiling and evaporation. So, boiling happens at a defined temperature. Now, this is different from evaporation because this actually happens at any temperature. A puddle on the street after it's been raining will evaporate at any temperature. It'll evaporate the temperature outside and that puddle will disappear. It doesn't actually boil. Boiling, again, happens throughout the liquid. Compared to evaporation, that happens at the surface. Now, you might be thinking, why is this knowledge important? And how could we apply it into context? Where might AQA apply this knowledge and get you to think about it? Well, actually, let's think about the winter when it starts to get cold and it starts to freeze at night. Of the time, the gritters will go out. But why does that happen? So we're going to have to think about the application of gritting the roads. So, why do we grit the roads? Well, actually, when we grit the roads, we actually spread salt and grit. And there's two elements to this, and that's important. First of all, the salt lowers the melting / freezing point. Because it's going to be the same point. For example, ice will melt at 0 degrees. It will also freeze at 0. So it lowers the melting and freezing point. That means it stays as water for longer. However, because we've got lots of surface water now, we have to add grit. So if we add gritting, this actually increases the friction. Increases the friction between the road and the tyre. In this video, we've had a look at the state changes between the states of matter. We've had a look at the difference between boiling and evaporation. We've done some key definitions of a pure substance, melting point and boiling point. And then we've shown how we can apply this knowledge into context.